Hello, everyone. Good morning or good afternoon or good evening, wherever the case may be all over the world. This is Charlie Martin, and I'll be your host today for our webinar. And today we'll be talking about something called service-based architecture in 5G. And this is exciting. It's a concept that we're really been looking for a long time. And we now have the opportunity to open up a lot of new opportunities in 5G for operators to work with partners to provide even better and better services than we have today. So give me a second here, and we'll go ahead and get started. I'm going to go through a short presentation, and I'm also going to talk a little bit about award solutions. If you've never heard of us before, we've been in operation for almost 25 years now, and we've served over 255 clients over that time period. And we work with pretty much everybody in the ecosystem in communications. Excuse me. We work with chipset vendors. Excuse me, getting a little something to drink there. My voice is a little rough. We work with chipset vendors, network vendors, tool vendors, operators, service providers, and also application providers. We're recognized in Texas. We're based out of the Dallas-Fort Worth area in Texas, and we've been the official training partner for Mobile World Congress for 8 years now. So just a little bit of background about us. In terms of the things or people that we've taught and what we've taught over 100,000 students now in LTE, coming up on 20,000 students on 5G. We also have a curriculum on cloud-based technologies and network function virtualization, and we've taught over 25,000 students in that, and then a newer curriculum on data productivity, and over 2,000 students on that now. So just wanted to share a little bit more about us if you've never had one of our classes before or have never heard of us. About me, my specialty here at Award Solution is 3G, 4G, and 5G radio access networks. I'm definitely an RF head, an RF nut. I've got about 38 years in wireless communications now at both the operator and at the vendor. My specialty is network design, network optimization, and network troubleshooting. I'm glad to be your host. And then I'm going to ask you as we go through our webinar today to please mute your audio connection. Now, and you're already muted right now. I'm going to ask you please not record this. I'm going to record this anyway. Actually, I am running the recording as we speak. And what will happen is that after the webinar is done in a few weeks, you'll be contacted with links so that you can go ahead and download the presentation and also look at the video. All right, so that'll be done for you anyway. And I do ask that your phones are in silent mode. So what are our objectives for the next hour? We're going to talk about the concept of services-based architecture, or SBA, all right? And you'll be able to explain this concept after we're done. We want to illustrate the use of service-based architecture in the 5G core network. We want to detail the role played by the NRF and the NEF, something called the network repository function and the network exposure function. Let's see if I can get my pen to work here. For some reason, let's see, pen. Hold on. And it's not working with me for some reason. Let's see if I can turn this on to laser pointer. Okay, that'll work better. I'll use that. So we'll talk about the use of service-based architecture in the 5G core network. We'll detail the role played by the network repository function and network exposure function in service-based architecture. We'll explain the role of service-based interfaces, so standardized interfaces in realizing service-based architecture. and identify some of the SBA characteristics that are going to be incorporated in the 5G core. So first of all, what's the whole thing about service-based architecture? And what I'd like to go back to is what I remember about 12 or 13 years ago, is that I remember, and I was working at the vendor at the time, is that there was a worry in the world about the network operator's role being reduced to that of being a data pipe, all right? That the values of what people cared about, the consumers and the customers, whether they be consumers or business, cared about, you know, the devices at one end of the pipe, and then the applications. So what they cared about was actually at either end of the pipe. What were the applications upstream, right? So we have application servers talking to what? Software clients and user devices. And we were worried about the role of the network operator being reduced to a dumb pipe. And back then, very much you heard about businesses and applications providers going, there's a lot of value in the network. There's a lot of information inside the network. Why can't we get access to that information in the network? A big one would have been like location, for example, or presence. And an application provider would have said, can you not provide me that information? Well, guess what? Just cutting forward to today in service-based architecture, we now have this capability. I just want to get that clear at the very start of this webinar. We're addressing a request, a need from our customers and as network operators, and also opening up opportunities for ourselves to monetize things and to monetize information. Service-based architecture is going to allow the network operator to have a much better partnership with third-party application providers, internal application providers. So for a service provider, maybe, of course, think about it. You have your app stores today, your Apple app stores, your Android app stores. We've got all those applications, a huge ecosystem of application providers just for consumers. We've also got businesses who want to do applications over wireless. And for example, things like IoT, right? Internet of Things. Wouldn't they like to be able to very tightly monitor what's going on, pull information out of the network about what's going on with their devices? And wouldn't it be great if they could get access to that information? Wouldn't it be great if the network operator could provide access? So that's the real big value proposition going forward here. All right. So in terms of this chart, the philosophy that we're going to use in the 5G is one where we've got these three ends of the ecosystem here. And what we're going to do is we're going to say, as far as the 5G core is concerned, that any given network function, and what we have is what's called network functions, okay, can be a producer of services and also a consumer of services. Another way of thinking of that as being a producer of information or as a consumer of information. And we're going to have a third party called the broker, okay, and that broker is going to be the NRF or the NEF, all right, depending upon the situation, and we'll get into that. So in this kind of scenario, think of like a shopping mall here in the middle, and a consumer walks into there just like you or me. We walk into there and we want to find our services. Well, in this case, the analogy is the store that's selling a particular product. And what we can do is we can go up to a service desk here, all right, and ask for help. That's that third party broker, if you will. Of course, nowadays that can be done electronically as well, right? And that could be just one of those electronic signs that gives us the information to find the store where I can find the product. So that's the kind of the analogy that we're going to use in our 5G core network. And so we see here in this picture is that we have a network function, and that could be internal or external, and it needs to get information. It needs to get pass information to get information from these network functions here that are in the 5G core. And we'll see some of these acronyms spelled out in just a little bit. Okay, so that's the model that we're talking about, how we're going to do the 5G core. Very different than the way we've done the core network in the past in 4G and 3G, where it's been very 3GPP specific. We've had network nodes, and there are proprietary software on top of proprietary hardware, and we have very specific protocols in the way we do this. What we're going to see over the course of this hour together in this class is that we're going to onto a whole new way of doing things. Okay. So in this model, and I'm showing up here is the network repository function, the NRF. And these are two of the network functions in 5G, the access and mobility management function, AMF, and the session management function, or SMF. And if you don't know this already, there was a movement that started in the world, really started getting hot probably about 5 years ago. It was this whole idea of network function virtualization. Network function virtualization is saying, you know what? In the past, in our network, in our wireless network, we've had these nodes. They've been provided by vendors, and the vendors give us a very specific, again, like I said, proprietary hardware solution with the proprietary software solution on top of it. And then operators were, at the same time, were deploying data centers and getting very, very experienced at running and operating those data centers. And they could buy computing hardware at very good costs, all right? Because of their economies of scale. They would buy, hundreds of thousands of these servers. And they realized, hey, in the end, in our networking, in our network nodes, like an MME or an SGW or a PGW or an HSS, it's still software running on hardware. Why couldn't we move to a world where we have software provided to us by the vendors and we just use our hardware? Things like Dell or HP or Lenovo servers. We've been deploying these for years. We know the operating system really well. We know how to maintain them and run them. We'll do that. And let's just get the software from the vendors. That is the big idea about network function virtualization. So virtualized software on commercial off-the-shelf hardware. So we started moving in that direction. And then what happened is that for 4G, that really didn't open up. 3GPP didn't really standardize that kind of approach. But in 5G, they have. In 5G, they have defined all the network functions, virtualized network functions, how they work, the interfaces, the protocols, all that stuff. So 5G has opened up the wireless network now to network function virtualization. And that's why we have these terms now. These are virtualized network functions, okay? So in this new world, what I talked about was that model of where we've got the consumer and the provider of services, and we have that third-party broker. So here, the NRF is the third-party broker, and this is for internal. Think of the NRF as being the internal broker, and the network exposure function as being the external broker, as in, this is the broker for the internal consumers and providers of services like the AMF and the SMF, and them brokering the communications between them, all right, opening up access between them. And then think of the network exposure function as giving access to outside world partners, okay? So in this mode, what we have is that we have basically 3 steps that have to happen. We have to do service registration. So all the different internal network functions will go ahead and register with the NRF. It becomes the registrar. And so it knows all the services they provide. And then what can happen is any other network function can go to the NRF, do service discovery with it to find out what the services are that are coming from the other network functions, and then be authorized for the services. And then the NRF basically okays to open up the communications between the two. And I show here where the AMF sends a network function service request over to the SMF to get some information. For example, these are some of the quote services also being information. So right here, it can advertise to the NRF, the network function type, identification information, names of supported services, endpoint informations for a given service instance. And then the AMF can get that information from the SMF directly after they've both first done these steps 1 and 2 up here, okay? And in this new world, this is really interesting. If you're the type of person who reads 3GPP standards, very eye-opening when I was reading this. We still have reference point interfaces, just like we had in LTE. So you may remember that in LTE we had these S-based interfaces in the wireless network. For example, like S1 MME, S1U between the RAN and the core network, right? And then S5, S8, on and on, many S interfaces. We still have that in 5G. Okay, now they're called N interfaces, right? And these are called reference point interfaces. But the other new thing, very new thing now that we've done in 5G is we've defined service-based interfaces, all right? And what you see here is these are many of the different types of network functions now, virtualized network functions, and we spell out down below here for your convenience if you want to see really quickly. Right, for example, AUSF, that's authentication server function. Okay, AMF, accessibility and management, mobility management function. All right, so now we have all these functions and we've created these quote service-based interfaces whereby these network functions can talk internally to each other, right, to carry out transactions, send information back and forth, do messaging back and forth that's needed, communications, right? So that's very new and very it's very exciting actually if you read on about it and discover what we can do with that. So a little bit more about the network repository function versus the network exposure function. I kind of already let the cat out of the bag, if you will, that I said that these are both act as brokers, right? But think of the network repository function as being an internal broker, all right? It exposes producer network functions to consumer network functions. And what you may have already started to think of, if this may have passed through your mind, each one of these network functions is probably both a producer and a consumer of services. Bottom line, if you need the PCF to talk to the SMF, well, guess what? They're talking to each other. They're passing information back and forth. And it's possible at any given instance, one may be a consumer and one may be a provider, but they can switch those roles as well, depending on what they're doing. Okay, so the network repository function right here is going to be that broker. And each one of these network functions goes ahead and tells the network repository function what kind of services they provide. And then they all also essentially register. It's a registrar, right, with the network repository function, get authorized for the services, and they discover the services, and then the NRF can basically give permission for them to talk to each other. Okay. And then we have something called the network exposure function here. And this is a thing that it really gets me excited. This is addressing the issues and the demand that we had in the world from 12, 13, 14 years ago, where, wireless data was really taking off, right? Think about, when did data take off wirelessly? It really took off probably back in the 2008, 2009 timeframe. What happened? Well, the user device community cracked the big issue on how to make the user interface very easy to use. And it was Apple at the time, right? With the launch of the Apple iPhone, it's all of a sudden we had a new way of using a user interface that was super easy and convenient to use. All right. And then, so now we've got this network exposure function. What it can do is it can expose network events to external application functions. And when I say application function, don't be confused. An application function is a term that's used in the world of IMS. So IMS networks for providing services. So it could actually be either the operator themselves providing services through IMS, so operator hosted services. It could be third-party application servers, all right? For example, any application you can think of that you download to your consumer phone, whether it be Android or Apple, to those app stores, And if it's a client server type of application, then guess what? We can provide information about the UE to the external application server. All right, thing, and then what can help is it can use that information to provide better service and better direction to the UE using that type of application, whatever it may be. An application might be something like uh, let's see, a navigation application, right? You could be using a mapping application, right? And maybe because it gets better information about location, presence, type of access, QoS, whatever, it can react to that, right? And then alter the way it provides service to the UE. So we can expose network events, we can expose UE configuration, and also QoS information. So that could get again could be a consumer application to an app server. It could be a network operator provided service to a server in the IMS network. It could also be a business. So it could be a business application server. And the one that immediately pops to my mind is IoT, right? We may have our IoT devices in a factory and they're talking to a server, right, upstream. And that server, that application server, wouldn't we like to get some internal information, right, from the network? And what can happen is the operator has control over this. You can decide which of your partners, your third party partners, get what type of information. Okay, so that's really exciting. So then we can provide more value, right, to our customers. And we can also hopefully monetize this. All right, isn't it possible? 12, 13 years ago, application providers were saying, I would pay for that kind of information if you could give it to me. Okay. So how do we go ahead and do communications between our network nodes? So I'll be talking about the two different cases here. So here, for the network repository function and internal services, so what we show here is that there's two ways in which we can get, quote, services, right? So an internal, for example, in this case, I'm showing the access and mobility management function as a consumer of information. It sends a request to the session management function, and then the session management function can send back a response. Real simple, right? Straightforward messaging kind of stuff. But you can also have a mode in which we do notification subscription. So an AMF can essentially talk to the SMF, say, I want to subscribe to some notification services, all right? And then the SMF can send a notification when something happens, all right? So down here, for example, notify me when the access type changes. So perhaps the access type changed from 5G to 4G, or 4G to 5G, or 4G to, or 5G to Wi-Fi, right? I want to know when that happens, okay? So that's one way, or actually a couple of ways that we go ahead and get services. It's not surprising, through messaging, communications, right? And then also for the external case here, what we can do is our external application servers, right, whether it be business, consumer, or operator, can subscribe to the network exposure function for events. And then the network exposure function can go ahead and communicate with the appropriate network function, retrieve the event, and notify the application server. Okay. And for example, here we say the application function or the application server subscribes to the, wants to get a notification of a certain type, right? And then the NEF, the NEF instructs the network function that it wants to get notifications when certain things happen. And then it's told that, and then it notifies the external application server. By the way, we'll have, I will save some time at the end of our presentation for Q&A, okay? I see some good questions on the chat already, and I'll respond to those, okay? All right, going forward, it's doing this kind of or implementing the 5G core in this way, and then providing both these two cases, providing services internally or externally, we're going to use service-based interfaces, okay? And in the old way, and I guess I kind of already talked about this in the past, we had our defined network nodes, and I'll use LTE here as an example. We had the four basic evolved packet core nodes, S gateway, P gateway, HSS, and MME. And we built software and we did things in a way that we had been doing for a long time. Binary-based protocols. We were very, very concerned always about bandwidth because in the past, our network nodes could be separated by a lot of distance, perhaps. And we wanted to be very, very efficient with our bandwidth. And so we built things in a certain way up through the 4G timeframe. What we've seen happen over time is that we're moving more and more toward a cloud-based type of approach on providing services and also hosting our core network. We've seen that we've gotten more and more centralized and more centralized. Our nodes have gotten really, really powerful and have huge capacity. But then we've also been kind of watching what's going on in the way of the internet world. Okay, so what's been happening? We've definitely seen this big move towards network function virtualization, service orchestration, and cloud-based type of approach for hosting our core functions. And so when you go down here below, bandwidth is not necessarily such a big approach anymore. What can happen is that we can have all these network functions hosted in one facility, right? Or just a couple of facilities, and we can manage our bandwidth a lot better, all right? And a lot of times it's going to be local transport that we have complete control over in terms of latency and bandwidth. And then, so what should we do in the future with our approach on the way we have our core network built and how we do communications? Well, you know what we want to focus on? We want to focus on how do we accelerate services to market? How do we get things to work faster? How do we, how can we leverage that huge ecosystem out there of application developers? There's a huge ecosystem of application developers that have been working with those companies like Google and Apple and others, right? And so what we're going to do is that the way we're going to develop our nodes and develop our software, it's all changing. And the way I like to describe it is we're going to do things the way the internet does things. That's the way I like to describe it. Okay, so some good communications already. It turns out we're going to do communications between all these network functions is going to be via HTTP. HTTP, just like the internet. In today's world, we've got so many servers out there providing applications, right? And talking to clients and talking to each other. We're going to do it the way they do it, HTTP, okay? And then we're going to develop software based on JavaScript, all right? Something called JSON, JavaScript Object Notation, all right? And then we're going to use this stack here to the right, HTTP2 over TCP over IP, just like the way we do things in the internet world. Bear with me for a second. For some reason, my pen is having some issues with communication. All right. So in this world, we're going to use standardized interface definition languages. All right. And it's going to be something called Open API, right? The whole world is using this kind of stuff. And in the end, we're going to just really abstract away a lot of the communication details between the server and the client. We're going to develop things the way the world is developing things, not just 3GPP, the ecosystem of 3GPP with the vendors that are there for the devices and for the network nodes and all that. And what we're going to do is that we're just going to produce what's called YAML documents, YAML, and that's a very funny name actually. YAML stands for it's a circular definition it stands for YAML ain't markup language. YAML ain't markup language, YAML. So anyway, what you do is that in this kind of development, you produce these YAML documents, this interface definition, and then you go ahead and just feed it into these compilers, right? These IDL compilers, and they generate the software. And that software can be whatever you want it to be. It could be Java, it could be Python, it could be C++ or whatever. And we can develop both the client and the server application. And then when we deploy, guess what? They're talking to each other over HTTP over TCP. Okay, very internet way of doing things. And then in terms of service-based architecture, I'll say one thing good thing that 3GPP does is that whenever possible, it adopts protocols and interfaces that have already been defined in the world. It doesn't have to reinvent everything. And so as you've just seen, our new 5G core network, the network nodes, they're just like, they think of them as like web servers, right? Talking to each other. And we'll have all the functionality that we'll have in that type of environment, all right? We will have this, quote, stateless network functions where we decouple the computing from the storage stuff. This makes for much more efficient communications between nodes. We'll have load control and overload control. We'll have the things that TCP, TCP gives us overload control. We'll have some new functionality in 5G messaging. This is called a service-based interface message priority mechanism. So our 5G messages can have a header in front of them that gives a message priority to them that helps with overload control and load control. We'll use HTTP routing mechanisms, okay? We'll use security mechanisms that are already in place for the world of internet, things like TLS, transport layer security. There is something called OAuth, OAuth 2.0, that's used for client server authorization. We'll reuse that. And we will have something called SEP, and that's on the next page, I believe. And that's called Secure Edge Protection Proxy. I would write this out if I could. My pen's not working right now. I apologize. Secure Edge Protection Proxy, SEPP, and those will be between the network functions, all right, to provide protection for them. And with SEP, you basically go through a process where the different network functions go ahead and they do a capability and parameter exchange between them, and then they start using something called, I like to call it JOSE, JOSE, right? JavaScript object signing and encryption. So now we can use Java encryption between the virtualized network function. So we're just going to be able to use reuse a lot of things that are there. We're going to use this SEP capability, and then we're going to always try to stick to this idea of extensibility, where for a given type of capability or function, we'll provide the framework for that function, and we don't necessarily have to force one type of implementation. And so, for example, there's something called Extensible Authentication Protocol, EAP, we use for authentication. And it turns out within EAP, there's many different types of methods for doing authentication. And so that's what we mean by extensibility, right? For example, also the way we do the routing IDs in HTTP, you can provide different types of IDs. We know something called URLs, right? Uniform resource location, but the bigger term is actually called URI, uniform resource identifier, right? And there's different ways of doing anything under that. So that's what we'll do. And then in terms of deployment considerations, so this is big. I mean, I'm mostly a RAN person by definition, but I've done a lot of core stuff in my career as well. I've worked on 3G core and 4G core. A long time ago, I worked on WiMAX core, if you remember that. So in this world, really, we're set up for doing this whole idea of software-defined networking and network function virtualization. we weren't really fully opening up the network, the wireless network, all right, as in 3GPP defined network to that in the 4G timeframe, but we've definitely opened it up in the 5G timeframe. Okay, the interfaces, the definitions, all the stuff is there. As you've seen, 3GPP has said, we're just gonna go, let's just go the internet way of doing things, right? All our network nodes now communicate with each other, doing things the way the internet does things, all right? We're going to, in this world of software defined networking and network function virtualization, do things like orchestration, service orchestration, right? And we know that within the 5G core network itself, if we do this NFV stuff, we're going to have an orchestration capability in there. What the orchestration does is really, it's about automation. It's about automating all the tasks that we have to do to support a service. So that means designing the service, putting all the resources together, all the pieces together for the service, and then making it work, right? So orchestration is going to become big, and then in this new world, you know, internally within a PLMN, a public land mobile network, right? So within an operator's network, we're going to be using the HTTP capabilities and HTTP routing and the SEP capability that I talked to you about for security. And then we're going to be using these routing URIs to set up communications between all the different network functions. The URI, remember, Uniform Resource Identifier, has multiple different types of identifiers. One of them is a URL. We're all familiar with URLs. So we'll use these URIs for setting up communications. And then we can also communicate between different PLMNs for things like roaming. All right, but we're going to be doing it in this new world, very internet-like, and I think it's fantastic. All right. So let me do a real quick summary, and then I'll open up for some questions. I see there's a couple of questions already in the chat. I urge y'all that if you have questions, go ahead and send them in the Zoom chat. So SBA, service-based architecture, will organize the structure and streamline the interaction between the producer and consumers of network function services. All right. 5G core employs service-based architecture. All right, it's given, it's in there to enhance the usage of 3GPP networks within and outside of the trusted domain. So what we do is we set it up so that internally they talk to each other with this model, right? Where we've got the NRF, but we also have this ability to talk to outside trusted third-party partners. And I think of them as three of them. There's external consumer application service, or external consumer applications, external business applications, and then kind of internal operator provided applications. Okay. The NRF will standardize the interaction within the networks, while the NEF exposes internal network events to outside consumers, such as, when I say application function, is a good question there. I really mean, think of it as application servers. All right. And IMS has the term AAF, application function, as an application function servers. They're still app servers. Okay. Service-based interfaces will employ the use of APIs, standardized APIs for interaction amongst the network functions. And then we'll use YAML scripts basically to develop the software. Okay. And then we'll have all the different functionalities that we had before in our networks, you know, the functionalities of how to route information, how to handle security, how to prioritize messaging, load control, et cetera, et cetera. We have all those capabilities, but guess what? We're moving to a world now where we're using the things that the internet uses. Okay. And with that, that's the end of our presentation. Just showing a couple of these codes here. All right, if you have a code reader on your phone, you can just hold it up to the panel. You can follow us on LinkedIn here to the left, and you can join my LinkedIn network here to the right. I have been teaching for about 10 years here at Award Solutions, and I do try to get back to anybody who asks me questions. All right. And then, so I'll leave that up there. Quick recognition of codes. And there's a couple of questions on the chat. So let me go ahead and attach my keyboard. I'll answer it verbally, but I'll also chat back. So application function, I hope I explained that. With application functions, I'm really meaning, think of it as the application server. All right. So we're going to have business. Think of this as the application server, whether it be consumer apps, business. I really think IoT really quickly, or operator provided apps over IMS. And in IMS, the world of IMS service networks, there's actually a term called application function, which means the application server. Okay. And we talked about the communications being via HTTP between network functions. HTTP 2.0 actually. And yes, you will get a communication in the next couple of weeks with a link to the presentation and also a link to where you can view the video of this. So give you links for the presentation and the video. Okay. All right. Are there any other questions? All right, then, folks, that's the end of our webinar. Thank you very much. Appreciate your being in the webinar with me, and be looking for those communications in the next couple of weeks. You will be contacted. Okay, you'll get an email, several emails. And thank you. Have a great weekend, and stay safe, everybody.